Here we go. Higher order derivatives. All right, so here's the notation for our first derivatives. We've used them a bunch. Now watch this. Second derivative, no big surprise on those. But look at this. So this is very strange notation, but here's my opinion as to why this is what it is. We want to have a notation here showing that it is the second derivative. This is not an exponent. This is just saying the second derivative. Now, that's kind of like saying this. All right, let me show you. This could be thought of as the derivative with respect to x of y. So thinking of this as actually just like a fraction. And so if I wanted to throw the 2 in there, then it doesn't make sense to give it to the y. It makes sense only to give it to the derivative notation, the second derivative of y with respect to x. And I know it's strange there, but it's kind of like the 2's just floating at the end. But we didn't want to give it to the y because the y is your function. Okay, that's my opinion. Okay, no one's ever said that to me, and I've never looked it up. I've just always assumed that that's what that meant. Okay, so this makes sense. So that kind of leads straight into that, what I was just saying. So instead of y, f of x. So this is unusual notation. Usually they would use f of x instead. All right, so then for the third derivative, and then the fourth derivative, once you get past the third derivative, they stop using the tick marks because they can make your eyes cross. And so they put a little parentheses instead of the tick marks to tell you the fourth derivative, and the parentheses then alert you to the fact that it's not an exponent. And in this notation, it's never an exponent. Never, ever, ever. It will never be an exponent. So this is always what derivative you're taking. Okay. Now, you're not going to believe this, but so if this was position, that would be velocity. All right. No, sorry. Yeah. If I had position, that would be velocity. That would be acceleration. This is actually called jerk. It's called jerk. I'm not kidding. And that's called snap. And the fifth one is called crackle. I'm not joking. And the sixth one is called pop. And if you don't believe me on that, feel free to look it up. Okay. It's crazy. Crazy, crazy, crazy. Might win you money on a game show one day. Okay. All right. Now, okay. So this says, okay, let's go straight into example 6 then. It's asking us to take the second derivative of f of x. Okay. So we're just going to take the derivative and then we're going to do it again. All right. So here we go. So, and our applications abound for this. That's why I love calculus. I mean, I love it. All right. So f prime. The 3 is going to drop down. I'm going to have 9 halves x squared. Okay. Plus 10x minus 6. And that's, of course, 0. All right. And then second derivative, which is the answer that they're looking for here. So the second derivative is going to be, 9 halves times 2. Okay, that was cool. That's just 9. X to the first power plus 10. Done. Fifth derivative of this one. Wow. Okay, fifth derivative. So f prime of x is going to be negative 12x cubed plus 21x squared minus 10. Check me for mistakes because it could happen. F double prime, or the second derivative, is negative 36x squared plus 42x. That goes to 0. F triple prime, and this is the last time we'll do that, is going to be negative 72x plus 42. F 4, the fourth derivative, that's the only way I know how to say that. The fourth derivative of f is negative 72. And then the fifth derivative of x is 0. All right, so here we go. So that's the equation for velocity if this was a position function. We'll be practicing the hound out of that. That's the whole next unit. All right, so so if that's position, velocity, acceleration, jerk, snap, crackle, and then the sixth one also would be 0. So pop would also be 0. I've never been asked a question about snap, crackle, or pop. You got to be kidding me that that's what those are called, but they are. Okay, 32 of them. All right, we got to see if there's a pattern here. All right, so let's get going on this. So let's just say the first derivative, I guess I'll use the same notation. Let me just say I'm going to just call f of x. I don't want to use that notation right there. So f of x is sine x. All right, then here we go. F prime is cosine. All right, f double prime is negative sine. F triple prime is negative cosine. And then f, the fourth derivative, it's hard for me to say, is back to sine again, and then the cycle continues. Okay, so what can we say? All right, so if I'm back to this again, where so then we would say that'd be 5, 6, 7, 8, right? 9, 10, 11, 12. It looks like every, okay, so all of those are divisible by 4. That's one less than a number divisible by 4, 2 less than divisible by 4, and 3 less than a number divisible by 4. True? So 32 happens to be divisible by 4. This is sine x. Okay, the cyclic nature of this, it's going to repeat every 4. So yeah, absolutely. That's exactly what's going to happen. All right, so what about on cosine then? So let's say y prime is negative sine. Okay, y double prime is negative cosine. All right, y triple prime is sine. And then y, the fourth derivative, I should say, is backed with what we started with, and then the cycle begins again. All right, so in again we have multiples of 4. So if I have a multiple of 4, it's going to be cosine. 1 less than that would be sine. 2 less than that would be negative cosine, and 3 less than that would be negative sine. All right, so what about 867? All right, how does that work out? All right, here's what I know. 800, okay, of course, is divisible by 4, so I don't have to worry about that. Then I just have to worry about the 67. So the 67, let's see. Let's think about that for a second. 67. Okay, so it looks like 60. Okay, so 68 is a multiple of 4. Yeah. So 67 is 1 less than a multiple of 4. That's going to put us at this one less than a multiple of 4. Took me a little while on that. So this 867th derivative of this is going to be 1 less than a multiple of 4, and that is sine x. Oh, let me say a little thing. Knowing that the 800 was divisible by 4, that just starts all over at 801, right? So 801, 802, 803, 804, and I keep going. So I can still do the same thing. So I had to pause for a second and think about 67. But 67 is 1 less than a multiple of 4. That makes it sine x. Woo!